Hey everybody, what's going on? It's Joel Irway with dailyfeexamprep.com, and in today's probability lesson, we are going to be talking about combinations. Just a quick shout out to Sheldon. He had recommended that we talk about probability on my content request form. So if you do have any specific requests for content request or for content you want me to cover for FE exam preparation, shoot me an email at topics@dailyfeexamprep.com or head over to my website and you can fill out the comment box there. So let's get started with this quick lesson. Okay, so the goal of this lesson by the end of the video is that I want you to have an understanding of when to use combinations in probability. Also, we're going to learn how combinations apply to a given data set, and of course, we're going to learn how to solve for combinations. So a quick overview of how this lesson is going to be set up. First, we'll define what combinations are. We'll learn when to use combinations and what keywords to look out for when you're looking at a problem. And of course, we'll go through an example. So let's get right to it. So combinations, the definition of a combination is a combination of a particular data set of something is the total number of times a subset of that larger group can be arranged where the order is irrelevant. Okay, so that gets a little confusing, but don't worry, we'll break it down in just a little bit. So it's used to count the number of ways a particular arrangement can be made from a given set of data. And the formula is given on page 33 of the NCEES Supplied Reference Handbook, version 9.2. And it's given right here. So it's given as a couple of different ways. Okay, so we can, it's given as C with the superscript N, subscript R, or the actual formula is n factorial divided by r factorial times n minus r factorial, and it's also given as n choose r, or NCR. Okay, where the exclamation point obviously is factorial. N is the number of elements to choose from in the larger data set, and R is the subset group size that we want to arrange for the combination. So when do we use combinations? Well, we use combinations when we're analyzing a group and order is not important. We use combinations when we are asked to find the number of combinations of n items taken R at a time. And the keywords to look out for are when order of the items within the subset are not important. So let's take a look at an example. So the example is the example that we have today is a band has 4 songs in a particular album and is asked to pick 2 songs to play at a given event. Okay, how many combinations can the band have where the order of the songs is not important? Okay, so we know that n, which is our value, n is the total number of songs that they have. It's the larger data set, which is 4, and they are asked to produce a subset of 2 songs for this event. Okay, so R, which is going to be our subset value, our subset group value is going to be 2. So what does that look like? Well, the formula then is going to be 4 choose 2, which is going to be 4 factorial divided by 2 factorial times 4 minus 2 factorial. Okay, so 4 factorial is 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. Okay, then we just take the difference between the two, and then we find that factorial, which just so happens to be 4 minus 2, which is 2 factorial, okay? And, okay, so it looks like I didn't properly write that out, but yeah, 2 factorial obviously is 2 times 1. And then finally, 4 choose 2, once we multiply it all out, is going to be 6. So let's take a look at it visually. Okay, so a visual representation. So we've got on our left-hand side is our n value, which is the total number of songs. So we've got song 1, 2, 3, and 4. Okay, so how many different groupings can we make of the 4 songs without order being important? Okay, so what we have is 6 different groupings. We can have 1 paired with 2, 2 paired with 3, 1 paired with 3, 3 paired with 4, 1 paired with 4, or 2 paired with 4. Okay, so obviously order is not important. I can't stress that enough. When you talk about combinations, order does not matter. Okay, you're really just looking at how many different subset groups can you have in the larger group. Okay, so thank you so much for watching this quick video. Please help help me build and grow this community, go to dailyfeexamprep.com and comment on this video and let me know what you think. So please share it with your engineering friends, share it with other people that you think might find value to this and help me grow this. Or you can subscribe to my YouTube channel, youtube.com/dailyfeexamprep, and like and share the videos with your engineering friends. So please check out all my videos at those sites and let me know what you're struggling with so I can help teach it. Go to dailyfeexamprep.com/content-request and let me know what you're struggling with so I can record a video and teach it just like I'm doing right now for Sheldon. Or you can also shoot me an email at topics@dailyfeexamprep.com. So that's it for today. Thank you so much for watching, everybody, and I'll see you in the next video.